morning. I am Dr. Sathya, working as Assistant Professor, Department of Chemistry, SNS College of Engineering. Today we are going to discuss an interesting lecture series, UV-visible spectroscopy. So what is spectroscopy? So this is a prism. When the light is absorbed and enter to the prism, it will be give the different colors. So the study of the absorption and emission of light and other radiation by interact with the matter. So this is called the spectroscopy. So the different types of spectroscopy is available. So one is the emission, absorption and scattering. So what is the emission spectroscopy? When the light is enter into the prism and emit some radiation, it's called the emission spectroscopy. So the types of emission spectroscopy is the fluorometry, flame photometry and atomic emission spectroscopy. And other type is absorption spectroscopy. So the different types of absorption spectroscopy is there. One is the UV-visible, IR spectroscopy, nuclear magnetic resonance spectroscopy and atomic absorption spectroscopy. So in these absorption spectroscopy, the light will be entered to the prism. The sample solution will be absorb some radiation, observe and give the wavelength. So in same region in IR spectroscopy, in vibration of molecules, in the absorption of light and the molecules will be vibrated. So the different types of vibrations are available, asymmetric, symmetric and bending like that. The scattering spectroscopy, when the light is entered to the sample, some scattered in the light intensity. For example, in Raman spectroscopy. So in previous slide, we know that the splitting of light in the different wavelength. In particular color, it will be the particular wavelength. For example, in our laboratory, we use an FAS solution. The wavelength is 480. For example, copper sulfate wavelength is 520. So this prism will be split into the rainbow of colors. So in UV-visible spectroscopy, it's according to the Beer-Lambert's law. So what is Beer-Lambert's law? The absorption will be interact with or directly proportional to the path length of the cell and concentration of the cell. For example, concentration of the solution will be thicker or very strong concentration. The absorption will be the high absorbance will get. So the absorption is directly proportional to the concentration of the cell and path length of the cell. So in this diagram, we'll explain Beer-Lambert's law. When monochromatic radiation is passed through the homogeneous solution and will be the detector will be detect the what is the intensity will give the solution. So A is equal to epsilon Bc, it's a Beer-Lambert's law. So this is a different electromagnetic radiations in our waves and radio waves, microwaves, infrared, UV visible, ultraviolet, X-rays and gamma rays. It will be give the some different wavelength. In UV region, the wavelength will be 200 to 400 region. For visible, 400 to 800 nanometer. So in visible region, 400 to 800 for visible. In UV, 200 to 800. Here the light source will be used for UV visible, deuterium and tungsten. Deuterium for UV visible and tungsten for visible. So in this diagram, the UV visible instrumentation diagram, the light source will be give some light to enter into the enter slit and disperse some different wavelength. We have monochromator for to give the narrow band of wavelength. So single wavelength and absorbs the mirror and finally it's enter into the reference and sample cell and finally we get the intensity of the light from the detector. So finally we got the UV visible length of wavelength of the sample. This is one of example for UV visible paranitrophenol. Here 300 to 400 we have some broad peak. It's called maximum wavelength for paranitrophenol. Thank you. So in this section we are discussed about the spectroscopy, different types of spectroscopy. So what is the UV visible spectroscopic instrumentation and what are the lamp, I mean source will be used for UV visible spectroscopy. Thank you.